Okay, so let's say you have a 3 kilogram mass object. You're pulling up at an angle of 38 degrees. Calculate for me what is the apparent weight of this object and what is its acceleration. And then part B of the question is, what's the minimum F that I need in order for the object to have to be lifted off the table? What is F min for object to lift off? In the case, like in the case of an airplane, right? After certain forces applied by the buoyant force of the air, the plane lifts off from the table. So you're going to learn what does that mean when we say lift off. Okay? Okay, so part A. You take the forces again, you break it up, do a free body diagram, you have F 15. So you break, the force has two components, 15 cos of 38. 15 sine of 38. Then you got the normal force. Then you got the weight, which is what? Is the weight 3 kilograms? No. Now, the 3 kilograms is the mass. A minute ago when I gave you the car is 6,000 pounds, that was the weight. But here, I'm giving you the mass because it's 3 kilograms. So you got to change that to weight. 29.4 newtons is the weight. Okay, so now in the x direction, in the y direction, there's still no acceleration. The forces cancel in the y direction. So we have n plus 15 sine of 38. In the vertical y direction, you have n, you have 15 sine of 38, and then in the negative direction, you have negative 29.4 equals to 0. Okay? So from this, we can calculate the normal force. Okay, the normal force is equal to 29.4 minus 15 sine of 38. That's the normal force right there. $20. 20.17 newtons. That is the apparent weight. Notice in the part A here, I didn't even ask what is the normal force. When I ask what is apparent weight of an object, I am already asking what is the normal force. Okay? In other words, the normal force is the weight that an object feels that it is. Here's another way, let me put it. If this object was riding on top of a scale, let's say instead of riding on top of a table, there was a weight scale on it. What would the scale be showing? What would the scale be showing? Well, the scale would be showing the apparent weight. The scale never shows your actual weight. The scale only shows the mutual force that you guys are exerting on each other. Okay? This guy here wants to fall, but the scale is going to support it so it doesn't fall, right? So the scale supports the 3 kilogram object with a normal force. The 3 kilogram object in return exerts a force down on the scale with a force of equal to the normal force. So the mutual force between them is N, between the scale and the 3 kilogram, right? Here's how it all starts. The 3 kilogram, the gravity tells the 3 kilogram to go down. The scale says, no, I'm not going to let you go down. I'm going to support you. And then the scale in return says, okay, I'll return the favor by pushing down on you with the force N. And then the scale goes down, and it has springs on it. And because it goes down, it's able to read the normal force, N. Okay, so the scale only tells you what you think you weigh, not what you weigh, what you feel you weigh. Okay, so if somebody's pulling up on an object, what is that going to do? It's going to give it a little lift. So it's going to make it think it's less heavy than it is. Okay, so the normal force is going to, the scale is going to read 20.17. Which is why whenever you're at a doctor's office and they're weighing you, and if you don't want them to see that you've gotten heavier, you kind of go like this, and when the doctor's not looking, you kind of push down on something close to you. Okay, don't let them see you. Go down. Okay, because when you go down, the table is now going to push up on you, and now the scale doesn't have to push as hard. Okay? When you want them to see that you've gained weight, like you're a boxer or something, you need to go to the next higher scale, so you can then push up, and then it pushes down on you, and then the scale now has to push harder, right? So by doing that, you can change your normal force. Okay? Okay, what is the A now? What is the acceleration A? The A is equal to 15 in the x direction. We have 15 cosine of 38 is equal to 3 times A. The mass is 3. Okay, so 3.94 meters per second squared. Okay, so we got the acceleration, and now once you have the acceleration, if the problem asks other questions about it, like what is the final velocity, how far is it going to travel after a certain time, then you can use the equations of kinematics to answer any other kinds of question. Okay, now let's answer part B. What is F min? What is F min for liftoffs? In other words, what's going to happen is if I keep exerting more and more larger forces, I'm going to give it such a lift that the normal force is going to go to 0. That's what happens, by the way, anytime you lift anything off the table. Let's say